A great day to one and all. I am Kim J.C. Ensho, and today I will be discussing this review for International Mathematics Olympiad competition of Southeast Asia for grades 8 to 11. So I will be giving you 30 problems for today, and I hope that you will do your best to solve these problems related to geometry. All right? So feel free to stop the video from time to time and solve on your own. And if you are ready, feel free to continue the video. And let's see if your answer is the same as mine. All right, with that said, let's begin with item number 1. The ratio of an interior to an exterior angle of a regular polygon is 3:2. How many sides does this polygon have? When we speak about regular polygon, all of its 5 sides are equal in length, and all of its 5 interior angles are also equal in terms of measure. So what do you think is the answer to this question? With that, let's have the following. We know for a fact that if you add the measure of an interior angle and its corresponding exterior angle, then its measure is always 180 degrees. In other words, an interior and an exterior angle of a regular polygon are always supplementary. And since the ratio is 3:2, for now, let x be the greatest common factor of the measures of these angles. And so the interior angle will be represented by 3x, and the exterior angle is 2x. Anyway, 3x is to 2x is still 3:2. And their sum is 180. So we have here 3x plus 2x equals 180 degrees, and that gives us 5x equals 180 degrees. Dividing both sides by 5, that's 180 divided by 5, you will get 36. Hence, the GCF is 36. And we could actually determine the interior and the exterior angles here. So the exterior angle is represented, remember, it's 2x. So 2 times 36 degrees, so we have 72 degrees. And it follows that the measure of an interior angle is 108 degrees. How come 108? Because of 3 times 36. But for now, I will utilize the measure of an exterior angle. And that is, we know that a basic concept in geometry is the exterior angle of any regular polygon is equal to 360 degrees divided by n. And so we are given the exterior angle, which is 72 degrees, and we will be solving for n. So doing algebraic processes, we could say that n, or the number of sides, is equal to 360 degrees divided by the measure of an exterior angle. Hence, n is equal to 360 degrees divided by 72 degrees, or n is 5. Hence, this polygon has 5 sides, or it's also known as a pentagon. I hope you got item number 1 correctly. Let's move on to item number 2. 3 concentric circles. When we speak about concentric circles, they share a common center. Have radii 3, 4, and 5 cm. What percent of the area of the largest circle lies between the other 2 circles? So what do you think is the answer here? What percent? So in this case, the largest circle has a radius of 5 And therefore, the area that we're looking for is between the circles with radii 3 and 4. And what percent of the area here is between that of a circle with radii 5 cm. So to do such, it's important that we get the area between the two circles with radii 3 and 4 cm. And we know that area of a circle is pi r squared, right? So we have here pi times 4 cm squared. This is the area of the circle with radius 4. And the area of a circle with radius 3 cm is pi times 3 cm squared. So that gives you 16 pi cm squared multiplied by 9. I mean 9 times pi, which is 9 pi. And in this case, so we have here 16 pi cm squared minus 9 pi cm squared, which is 7 pi centimeter squared, which is the area between the two circles with radii 4 and 3 cm. And the area of the largest circle, or the circle with radius 5, is pi times 5 cm squared, or 25 centimeters squared in this case. And so you could see what fraction of 25 cm squared is 7 cm squared, 7 pi cm squared. So for such, all we have to do is divide. Hence, we have 7 pi cm squared all over 25 pi cm squared. And we could see here that pi and cm squared are common factors. So we could actually divide them and become 1. And so you have 7 over 25. And multiplying both numerator and denominator of 7 over 25 by 4, you will arrive to 28 over 100. And in this case, 28%. I hope you got 28% correct. All right. So far, so good. Let's proceed to problem number 3. Okay, try this. The corresponding sides of two similar triangles are in the ratio 2:7. If the area of the smaller triangle is 36 meters squared, what is the area of the larger one? What do you think? All right, I will divulge the answers now in 3, 2, and 1. So, remember this. If the ratio of when we speak about similar triangles, there's corresponding angles are congruent or equal in measure, and their corresponding sides are proportional. And if the ratio of the two sides is 2:7, expect that the ratio of their perimeter is also 2:7. Okay? Because the ratio of the perimeters is equal to the ratio of the two corresponding sides. But what do you think is the ratio of their areas? Is it still 2:7? And the answer is no. Remember this. The ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. You can actually verify this by providing an example. So you could see that if the ratio of the two corresponding sides is 2:7, then the ratio of their areas is, you just square this, 2 squared, that's 4, 7 squared, that's 49. And thus, the ratio of their areas is 4:49. And now, we know the area of the smaller triangle, and let x be the area of the larger triangle in meters squared. So by direct proportion, by proportion, we know that 4 is to 49, ratio of the smaller to the larger area, is equal to the 36 is to x, smaller to larger area. And remember that in a proportion, the product of the means equals the product of the extremes. And so we have here 4 times x. Extremes are the ones that are outside, and the means are the ones that are inside. So 4 times x, you have 4x equals 49 times 36. And dividing both sides by 4, we have x equals 49 times 36 divided by 4. And it's better to divide first and simplify before multiplying, because in that way, you will be dealing with smaller numbers. And besides, multiplying large numbers is quite, at most times, is easier than dividing larger ones. So I will divide 36 by 4. 36 divided by 4 is 9. And 9 times 49 gives 441. Hence, the area of the larger triangle is 441 meters squared. Okay. So far, so good. Okay. Number 4. How many diagonals does a decagon have? When we speak about diagonals, these are segments that connect two non-consecutive vertices of a certain polygon. And if you could remember, I think this one is basic, no? Maybe you are aware of the formula, and that is the number of diagonals D is equal to n times n minus 3 all over 2, where D stands for the number of diagonals and n stands for the number of sides of a polygon. Since a decagon has 10 sides, so n is 10, by substitution, that's D equals 10 times 10 minus 3 all over 2, and that is 5 times 7. How come 5 times 7? Because 10 divided by 2 is 5, 10 minus 3 is 7, and 5 times 7 is 35. Hence, if you will draw a decagon and draw all the diagonals, expect 35 of them. All right. I hope you are doing well. Problem number 5. Consider right triangle ABC with angle B equals 90 degrees. Let D be a point on segment AC such that segments BD and AC are perpendicular to one another. If AB equals 3 and BC equals 4, how long is BD? So, I will now divulge the solution to this problem. Let's see if you got it right. So this is how the figure looks like. So B is your right angle. So AB is 3, BC is 4. And D here is the foot of the altitude BD. And such, of course, BD is perpendicular to AC, meaning they form a 90-degree angle. So how long is BD? There are many ways of doing a problem like this. I will just present one way utilizing the Pythagorean theorem. So by the Pythagorean theorem, we know that the sum of the squares of the two legs, in this case, AB and the square and BC are the two legs, is equal to the square of your hypotenuse AC. By doing such, we could say that the square of your hypotenuse, we have here AC, AC quantity squared, equals 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16. And if you add them, 9 plus 16 is 25. And if you will take the principal square root or the positive square root of both sides to solve for AC, we have AC equals 5 units. Don't be confused. It should be plus minus 5. But since we are talking about lengths, so in this case, we have to adapt the positive value and discard the negative values. So AC here is 5 here. But what happens next? How do we solve for BD? There's a technique here, and that is by utilizing the area of your triangle. Remember that the formula for the area of a triangle is base times height divided by 2. So in this case, if you will look at this perspective, the 4 is your base, the 3 is your height. So we have here 4 times 3 all over 2 here. So this is the area. But remember that if BD is perpendicular to AC, then it also, at a certain perspective, AC could serve as the base and BD could serve as the height. That's why this is the base, which is 5 units, 5 base times BD, which is the height, divided by 2. And you could see that I just multiplied both sides by 2. And to clear off fractions, 3 times 4 is 12. 5 times BD is 5 times BD. And since we are solving only for the length of BD, we will divide both sides by 5. Hence, we have 12/5 equals the length of BD. So this has to be 12/5. I hope you got it correctly as well. And if you did, congratulations. Number 6. The diagonal of a square is 8 centimeters long. What is its area? So there are many ways of doing this. Others would do the Pythagorean theorem. They would utilize the Pythagorean theorem to solve for a length of a side. And after getting the length of a side, then they will just square the result. No problem with that. But right now, I will present to you another way of doing that. That is, we have to remember this principle that diagonals of a square, rhombus, and kite are perpendicular with one another. And using their diagonals, their area could be found using the formula A is equal to D sub 1 times D sub 2 all over 2, where D sub 1 is the length of the first diagonal, D sub 2 is the length of the other diagonal, and you get their product and divide it by 2. And we know that for a square, all of its vertices are equal. That's why D sub 1 and D sub 2 for a square are in fact equal. So we have 8 cm times 8 cm all over 2. And 8 times 8 is 64 centimeters squared divided by 2. Then you get 32 centimeters squared. But if you do it the other way, no problem. What's important is we got the correct answer. And if you are following appropriate algebraic principles. Moving on to number 7. The diagonals of a rhombus measure 10 and 24. How long is the height of the rhombus? What do you think? So we can do it this way. So when we speak about the height, so it's about this length here. Okay? So how far is this with this one? Or how far is this with the other one as well? So to do that, we know that the lengths are 10 and 24, right? And based on this, okay, we all know for a fact that if you draw the two diagonals, then each diagonal bisect each other. When we say bisect each other, they divide each other into two equal parts. So let's say if this one is the longer one, the other one. So if this is 10, take note, this figure is not drawn to scale, okay? This figure is not drawn to scale. So if this is 10, and if this is 24, so 10 divided by 2, we have here 5, 5. 24 divided by 2, so this should be 12, and the other one is also 12. And remember as well that based on the previous slide, or on the previous item, diagonals of a rhombus are perpendicular. So these are in fact all right angles here. And for such, we don't know the length of that side x. Let's say the side of a rhombus is x. And since this is a right angle, then we could utilize the Pythagorean theorem to solve for x. That is, let x be the length of the side of the rhombus, and by the Pythagorean theorem, we have 5 squared plus 12 squared equals x squared. 5 squared is 25, 12 squared is 144, and their sum is 169 equals x squared. And the roots here are plus minus 13, but we are talking about the length of a side, so we will get the positive value, which is 13 units. So this is 13 units long. And we know that the area of a rhombus, based on the previous slide, is diagonal 1 times diagonal 2 all over 2, right? The first diagonal has a length of 10, the other is 24. So 10 cm times 24 cm all over 2, and that's where you got 120 cm squared as your area of a rhombus, this one. However, if you could recall, based on what you learned when you were in elementary, and suppose we let h be the rhombus's height, we know that the area of a rhombus is equal to its base times its height, right? And so we know that we don't know the base. I mean, the base here is x, which is 13 now. The height is something we don't know. And hence, what we can do is, by substitution now, by b, of b, which is in fact your x, which is 13. So you have 13h equals 120, and dividing both sides by 13, you get h equals 120 over 13. And this is the answer to our problem. I hope you got this correctly as well. Number 8. An A by B rectangle with A greater than B has an area of 40 square units. If A squared plus B squared equals 89, find A minus B. Take note, we are talking about a rectangle here, so A and B are both positive values. They are both positive values or greater than 0, and that A is larger than B. And since A here is larger than B, then A minus B is positive. So we will be looking for the positive value of A minus B. Now, solving for this one, we could actually begin using our given, which are AB equals 40 and A squared plus B squared equals 89. And how do we get A minus B? The technique here is by introducing or by subtracting both sides by 2AB. Remember, if you add or subtract both sides by the same quantity, you are still maintaining equality. You do not alter the equality, you preserve equality in this case. And you will know the reason why we subtracted both sides by 2ab. If we subtract both sides by 2ab, in this case, it will become this. A squared minus 2ab plus b squared equals 89 minus 2ab. But we know from the given that ab is 40. And so, what we will do is we will substitute this AB on the left-hand side. That's why it became 89 minus 2 times 40. However, on the left-hand side, we could actually see that a squared minus 2ab plus b squared is a perfect square trinomial, and that it could be expressed as a square of a binomial. That is why in your left-hand side, you have a minus b quantity squared. And a minus b quantity squared is equal to 89 minus 40, 2 times 40, which is 80. 89 minus 80 is 9. And so the square of a minus b is 9. And if you will get the square root of both sides of the equation, then you will arrive to a minus b equals plus minus 3. You took the square root of both sides, but we have to get we have to place plus minus before 3. But remember, as what we mentioned before, since a is larger than b, then a minus b has to be positive. That's why, since a minus b equals 3 or a minus b equals negative 3, but picking only the positive value, hence a minus b equals 3 in this case. I hope you got this item correctly, and if you did, congratulations. Let's move on to problem number 9. The two sides of a triangle measure 15 and 7 units. If the third side is an integer, what is the difference between the biggest and smallest perimeter of the triangle? What do you think? So for this case, let's say we don't know what the measure of the third side is. So let x be the measure of the third side. And we have to remember this, people. We have to remember this. If you are given the two sides of a triangle, then the measure of the third side or of the remaining side is always between the positive difference and the sum of the two sides. That's why x here is between 15 minus 7 and 15 plus 7. Hence, in this case, x is between 8 and 22. Take note that it's between, so 8 and 22 are not included, which means the smallest value of the third side is 9, and the largest possible value of x, it's less than 22, so it should be 21, because we are talking about integer values of the third side. Hence, the biggest perimeter minus the smallest perimeter is, remember, to get the perimeter, we add the three sides. So we have 15 plus 7 plus 21 if you wanted to have the largest perimeter. And the measure of the smallest side of the third side here should be 9. Okay? So 15 plus 7 plus 9. And if you subtract them, if you add them in the respective groupings and subtract, you will get 12, which is the answer to this problem. Or to make it simple, 15 minus 15 becomes 0, 7 minus 7 becomes 0. That's why you could just simply get the difference of 21 and 9, which is 12 in this case. Number 10. A regular pentagon and a regular hexagon share a common side as shown. What is x? So This is the pentagon here, a regular pentagon. This is the regular hexagon. They share a side. So how big is this angle X here? I will reveal the answer now, and let's see if you got it right. So remember, we are talking about regular polygons. And since they share a common side, say DC here, I may put labels. I let this be A, B, C, and D. And since DC is a common side, so therefore we could say that each the lengths of the measures of the side of your pentagon and hexagon are equal with one another. That's the reason why AC and CB are placed the same tick marks, because they are equal in length. And in that case, we could say that ACB is isosceles. Now, from here, let's get the measure of ACB, of angle ACB here. Remember, this is a pentagon, and to get the measure of each interior angle of a pentagon, we use the formula 180 times number of sides minus 2 divided by the number of sides. The numerator here represents the sum of all the interior angles of a pentagon, which is 180 times 5 minus 2. And since you have 5 angles, so you have to divide with 5. And that gives you 108 degrees. How about the other angle, BCD? This one. We are talking about a hexagon here. So the sum of all the interior angles is 180 times 6 minus 2. That's 180 times 4. And since we have 6 interior angles that are equal, that's the reason we divided by 6. Hence, each interior angle of a hexagon, or angle BCD in this case, is 120 degrees. And these are their values. And with such, I might ask you, how big is angle ACB here? ACB. Remember, this is like a circle here, right? And in a circle, that's 360 degrees. So all we have to do to get the measure of angle ACB, what we can do is that we can subtract 360 by the sum of 108 and 120, and that gives you 132 degrees in this case here. Okay. So with such, what can we do next? So what we can do next is, remember that if this is X here, this also has to be X, because these are the base angles of your isosceles triangle ACB. That's why these are, in fact, if this is X, this is also X. That's why to get the value of the remaining side, this is a triangle, right? This is a triangle ABC. And that's 180 minus 132. And dividing both sides by 2 because they're equal, we get 24 degrees. Hence, the correct answer here is 24 degrees. In fact, this is a bit longer, no? Because if you wish, what you could do is, if you could extend it here, this is also X here. This could be 120 as well here in this way. It's 120, and you could do so many things with that actually. No? All right. I hope you're doing well so far. Now,